Welcome to MrCScience.com's video on the mole. Now, a mole is not a little tunnel digger that you find in your yard. Look at that lifelike representation I got there. But mole in chemistry is extremely important. So let's first of all talk about how we derive the mole. So if we go back to our periodic table, we were working with carbon. And carbon had an atomic mass of 12.0, or 12 AMU. Now, from the last time our last video, we learned that 1 AMU equals 1.66 times 10 to the negative 24th grams. So if a atom of carbon weighs 12 AMU, we got 12 times 1.66 times 10 to the negative 24th grams. And we can use our little scientific notation, our calculator here. 12 times 1.66 equals 19.9 if we keep our significant figures. 19.9 times 10 to the negative 24th grams, or move that decimal place over one, bad arrow. 1.99 times 10 to the negative 23rd grams. So if one atom of copper weighs 12 AMU, or carbon weighs 12 AMU, that means one atom weighs 1.99 times 10 to the negative 23rd grams. Give myself a little more room here. So the concept of a mole is you take the atomic mass and you put it in a graph. So 1 mole of carbon is 12.0 grams. So this is kind of an arbitrary number, but just take your atomic mass, put it in grams. So let's take our 12.0 grams. If 1 mole of carbon weighs 12.0 grams, how many atoms are in it? Put that over 1 and multiply. We want to get atoms on the atoms, so we put that on the top. We want to get grams, put that on the bottom. Here we know 1 atom of carbon, 1 atom, weighs 1.99 times 10 to the negative 23rd grams. That's a 3. It looks almost like a 2. Now it looks like a really bad 8, but 1.99 times 10 to the negative 23rd grams. So if we go back to our calculator, take our 12 divided by 1.99, we get 6.03. 6.03. And when you divide, you subtract the exponents. Remember 12.0, bad. 12.0 grams is the same as 12.0 times 10 to the 0 power, because 10 to the 0 is 1, so 12. So times 10 and 0 minus negative 23. Minus negative 23 equals 23. And we're left with atoms. So 1 mole, or 12 grams of carbon, is 6.03 times 10 to the 23rd atoms. Actually, due to numbers we've used that are imprecise, our actual number is 6.02 times 10 to the 23rd atoms in a mole. Now this might look familiar from an earlier video. This is called Avogadro's number. And that works for all things. For every mole, we have 6.02 times 10 to the 23rd atoms. This means that we can relate atom to atom. So let's take a look at some other ones on the periodic table of elements. Okay, so here we are, periodic table of elements. So 1 mole of carbon was 12 grams. So now let's look at hydrogen. 1 mole, its atomic mass is 1.01. So 1 mole of hydrogen will be 1.01 grams. Grab something in the middle. Chromium, Cr, 52 atomic mass, so 1 mole of chromium is 52.0 grams. All of these have Avogadro's number. All these have 6.02 times 10 to the 23rd atoms. So if we take here, let's take a simple one. Let's take sodium. Sodium, 1 mole of sodium is 23.0 grams. And let's take chlorine. 1 mole of chlorine is 35.5 grams. Now we know if we make sodium chloride, NaCl, we take 1 Na, 1 Cl. So if we want to make this, we'll take 23.0 grams of sodium and we'll combine it with 35.5 grams of chlorine. And that'll give us 1 mole of sodium chloride, which is 23 plus 35.5 or 58.5 grams sodium chloride. So we can combine, so we know that we got 6.02 times 10 to the 23rd atoms plus 6.02 times 10 to the 23rd atoms. Since they're the same, they'll all match up and work. So now we can make the leap between our atomic mass and grams and work that for our experiments. We're going to do much more work on this later, but for now it's just kind of an overview. So it's important to know that atomic mass in grams is 1 mole, and that always has the same number of atoms, so that we can now use grams instead of atomic mass units. And we'll call that moles. And so 1 mole will react with 1 mole. Or water, H2O, has 2 moles of hydrogen plus 1 mole of oxygen. Hydrogen's atomic mass is 1 gram, or 1 mole of hydrogen is 1 gram, 1 mole of oxygen is 16 grams because its atomic mass is 16. So 2 times 1 is 2 plus 16, 1 mole of water is 18 grams. This is an important concept. We'll be using it from here on out, and you should, by the end of the class, really know it by heart. Relatively easy anyway. If you have any questions, feel free to drop me a line at mrc@mrcscience.com. Thanks.